This interactive figure illustrates the first derivative theorem for local extreme values. That theorem states, if f of x has a local maximum or minimum value at an interior point C of its domain, and if the derivative of f is defined at C, the value of the derivative at C is 0. In the interactive figure on the left side is a graph of a function that can be changed by clicking on the New Function button on the right-hand side. The local extrema at the input values of x equals c of the function's domain are labeled as a, b, c, d, or e if they happen to exist. And again, clicking on the New Function button will change the graph of the function. Since the derivative of this function is defined at each local maximum or minimum point, we can conclude that the derivative will be equal to 0 at each of those local extrema. So on the graph of the function f of x, there is a movable point P. As I drag point P along the graph of the function, at the top of the window are the coordinates of point P and the value of the derivative evaluated at the x-coordinate of point P. Where point P is located right now, the derivative's value is equal to 1.52. As I drag point P closer to the local extremum, the derivative becomes 0. The slope of that tangent line is 0. As I drag to another local extremum, this time to point D, again the slope becomes 0. Clicking on the New Function button, we can explore other functions and the values of the derivatives at these local extremum, but they should always be 0.